Hello my CET champions, how are you all? Today I am here with the session that you were all waiting for, right? The KCET PYQs of the chapter Continuity and Differentiability. It's one of the highest weighted chapter. Almost 5 to 6 questions are coming from this particular topic. So you need to be very much thorough with the PYQs, very much thorough with the concepts that has already been done. Let's test ourselves solving these PYQs from the last 10 years. Okay, so can we begin with the session? Last 10 years PYQs, we're going to quickly solve it and of course ace it to get any question correct in our examination from this chapter, Continuity and Differentiability. That is our goal. Let's begin. So outline, as I said, so we'll solve close to 30 plus questions. 30 plus questions. Again, all these are PYQs of KCET from last 10 years. From last 10 years. And these are not some odd 30 plus questions. These are hand picked. Means most important. Okay, hand picked. I have selected all these questions, means they are very, very important. So basically, most important PYQs, how many? 30 from last 10 years. From last 10 years. Let's see the question number 1. Okay, without wasting time, we'll start the session. Question number 1 now. What is there? Again, this is very simple question. Very, very simple question. Same question has been a PYQ of your boards as well. Even the PU2 boards has asked this question, and you know the answer is option number C, which is 2. Option number C, which is 2. Don't you know that? If you want, I can show you. Just simply differentiate the given function to you. Y equals to, we have, there's a square on tan inverse. Differentiate this. We are looking for derivative. Y2 represents second derivative and y1 represents first derivative. Okay, so differentiate now. If you differentiate once, we get the first derivative, which is y1, and for this we'll have 2 times of, we're going to use this as first form of the function is here, polynomial, right? Where is polynomial, sir? Where the whole power is 2. That's the polynomial function. Okay, so you're going to use that polynomial form first. So 2 times of tan inverse of x, that's the first derivative. Then apply the chain rule. Derivative of tan inverse of x, which is what? 1 upon 1 plus x square. This itself is the first derivative. This result we got from the use of chain rule. Okay, what is the next step? Same, take this on this side. So write 1 plus x square times of y1. How come, sir? Because we have something like this. Can you see? We have something like this. Yes. So right here 2 times of tan inverse, which is left on the right hand side of the equal to. Okay, differentiate once again. You're going to use here product rule, so use that. For this you'll have simply 2x left, simply 2x left. Y1 will be as it is. Next, keep this bracket as it is and differentiate y1. For that you'll get y2. Derivative of first derivative is second derivative, so y2. Okay, derivative of, we have done y1. For this part, 2 times of derivative of tan inverse, so again 1 plus x square. If you cross multiply this term on this side, what happens? You'll end up with the statement, right? Have a look. You'll have 2x times of 1 plus x square y1, 2x times of 1 plus x square y1, and for this you'll have 1 plus x square the whole square, which is this term, times y2 equals to, the number here left, 2 times of 1. How much is that? 2. Hence option is correct as option C. Clear or not? Very easy question. No doubt in this one. Very, very easy. Let me know question number 1. No doubt, sir. Comment section. Question number 1. No doubt, sir. I want all of your names to be read by me. Okay. Now question number 2. The function represents by the following graph. If graph is given, job is very simple. Continuous or not at point 1? Yes, continuous, sir. So at point x equals to 1. Continuous, because there is no break in the graph. What about differentiable? Give me the answer, all of you. Of course, non-differentiable. How come? Sharp corner. Sharp corner is present. Here, can you see? There is a sharp corner present over here at the point 1. So, of course, non-differentiable. For this side, we will have positive slope. This side will be negative slope. So, derivative is plus over here, the positive value. For this end will be negative. Hence, cannot be equal. Answer will be continuous but not differentiable at the point x equals to 1. Option A is correct. Continuous but non-differentiable. Okay, option A is correct. Question number 2 is done. I think simplest of all the questions which is possible. If you know the definition of differential functions, you'll know how to get it. Okay. Okay, question number 3 now. Fx is given as 3 sin pi x by 5x. For these kind of questions, of course, you can apply the standard limits rule, right? Divide this, multiply this here with pi. Again, both numerator and denominator by pi and pi to get sin pi x form, right? Or simply you can apply L'Hopital's rule. Apply LH rule. What's the meaning of this? How to solve this question? Remember, differentiate this, you'll get the limit value, right? I'll show you, don't worry. So they're saying it is continuous. It means limit will be equal to the function value. Continuous means limit of the function fx when x tends to 0 is equal to what? Your function value at 0. Limit fx x tends to 0 is equals to function value at 0. So function value at 0 is 2k. Okay, and limit of this will be what? 3 sin pi x divided by 5x. Okay, and we have limit x tends to 0. What I said, use the LH rule, mean differentiate under the limit. Have a look. You will have 3 as it is. Sin will become cos pi x. Differentiate pi x also, you will get over here pi left. Divided by 5 times of derivative of x is what? 1. And limit continues to be written as the same. X tends to 0 equals to 2k. If you substitute over here, what are you going to get? You will have this cos pi x means cos 0. So cos 0 is 1 into pi upon 5 equals to 2k. Hence answer for this will be what? 3k by 10. 3 pi, sorry, not 3k, 3 pi by 10. Option B is correct. Option B is correct. Have a look. Again, sir, so many steps. Do I have time to write in the examination? Of course you don't. So what is my limited number of steps over here? I need to write, what steps I need to write? This one, no, not required. This is not required to write. What about this? Not required actually. I can just write this step. I can just write this step. One step I can write and get the answer. Write one step and get the answer. This is a one step question. No need to write the step here, 1, 2 and the 4th and 5th one. Only this step is good enough to get the result for us. Only this step is good enough to get the result for us. But how can you know this step? If you have practiced these kind of questions. Okay, that comes with the help of practice only. Otherwise, it's not going to be that easy for you. Question number 4 now. Fx is given as 3x minus 8 and 2k. Same thing, continuous means f of x equals to, sorry, f of 5, will write directly, f of 5 equals to limit at x tends to 5. Do it. I get here, f of 5 means 3 times of 5 minus 8. Over here, limit is going to be what? 2k. How much is this? 15 minus 8 is 7, so 7 by 2 is my value of k. Again, one step question. One step question, very simple. Option B is correct. Option B is correct. Moving on. Question number 5. If y equal to log of 1 minus x square and a 1 plus x square, if you see this kind of question, simply use the properties of logarithms. Log a by b. Okay, log a by b is what? Log a minus log b. Log a minus log b. So write that. I get here y equals to log of the numerator 1 minus x square minus log of denominator 1 plus x square. Next step is to do what? Find derivative. So do that. I get over here dy by dx, derivative of this 1 upon 1 minus x square. By now I know that you all know the formulas. I have to accept that. Okay, if you don't know, revise right now. I have given you formulas in my previous sessions class. So go ahead, download the class notes and revise the formulas. It's very much important. Okay, you cannot expect right now for me to tell the formulas again and again. You have to remember, it's for your own good. Okay, so derivative of log will be what? This comes down, and if you use the chain rule also over here, chain rule for this polynomial function, so we'll get what? Minus 2x. You get what? Minus 2x. Correct, na? This will become minus 2x. Again, continue with this side. Derivative of this will be 1 upon 1 plus x square. And for this side, we'll have 2x because we have 1 plus 2x, right? So we have 1 plus x square, right? It becomes 2x. All right. Next step, dy by dx, take minus 2x common. We have here also minus 2x, here also we have minus 2x. See, this is 1, this is 2x into minus 1. So minus 2x, I have what? 1 upon 1 minus x square plus 1 upon 1 plus x square. Take LCM, take the LCM. Try to skip some steps. When you are solving this question, no, try to skip some steps. Try to solve some questions in your mind only. Develop your thinking ability to process the question. Okay? So, I am not doing that because I don't want you to skip on anything. I don't want you to be confused about anything. That's why. Not skip, confused about anything. So, this is cancelled. My answer is very simple. 1 plus 1 is 2, right? So, I get 2 times of this. So, minus 2x into 2 by 1 minus x power 4, which is minus 4x upon 1 minus x power 4. That's my final answer. Okay, so I think this is correct, option C. Okay, now how many steps is required to solve this question, sir? Okay, so we need, we need this step. This is important step. I need to know this. One step over here and maybe this one. 2 steps. Only 2 steps is good enough. This and this step is you required to solve the question. Only 2 steps is required to solve this particular question, number 5. Let's move on to question number 6 now. Answer is option C. A cos q theta, y is a sin q theta. Looking for 1 plus dy by dx, the whole square. Let's find dy by dx first. It's a parametric form question. It's a parametric form question. X is given in terms of theta, the parameter, and y also is given in the terms of theta, the parameter. So differentiate this, I get a 3 sine square theta, okay, a 3 sine square theta, and for this we get what? Cos theta, that's it. Derivative of sine is cos divided by a 3 cos square theta, and derivative of cos is what? Minus sine theta, okay. A and a is cancelled, 3 and 3 is cancelled. We get this sine cancel this sine, alright, and this cos cancel this cos. So I'm getting what? I'm getting minus tan theta. Am I right? I'm getting minus tan theta. Please check. Sine left over here, we have one cos left. So we have, and there's a minus sign, so minus tan theta is my derivative. Are they asking us this? No. They might give you an option like this. Please check, minus tan, so you can get the answer. No. What are they asking? They're asking us 1 plus this derivative, the square. 1 plus square of this, so it will become tan square theta. What is the answer? Sec square theta is my final answer. Option D is correct. Option D is correct. Option D is correct. Okay, have a look. Again, this is one step over here. That's it. One step question. If you're getting this as tan theta, one step if you get, it means your answer is sec square. Okay, so your answer is, this question is again one step problem. Question number 7 now. So that's why I'm giving you the entire steps which is required to solve the question, and what is the best you can do without any shortcut to get the result. And how can you achieve that? By a lot of practice, of course. Okay, because in this kind of question there's no tricks involved. Otherwise I would have given you that. Wherever I can give you a trick, I'll give you that. I have a question like that today. Okay, so Q is this, P is the determinant we have. I'm looking for dq by dx, derivative of Q upon with respect to the variable x. How do you do that? First find Q and P. So derivative, I have to find P over here. Let's do that. I get x square minus 1. Same way, find determinant of Q as well. So I'll find across x, what I'm getting, x into x is x square minus 1. So x square minus 1. Across minus 1 we can find the second term. What I'm going to get? X minus 1. Right now, x into 1 minus 1. And last is plus 1. The last term over here in the first row, I get 1 minus x. I get 1 minus x. Let's simplify. I'm getting x cube minus x plus 1 and plus 1 minus x. So it's giving me what? It's giving me x cube minus 3x plus 2. X cube minus 3x plus 2 is the value of my determinant of the matrix Q. matrix Q. All right, this is correct. So far so good. If I differentiate now this Q with x, what I get? Please check. I'm getting here 3x square minus 3, that's it. Because for 2 will be 0 and for x we'll get 1, so that's why I've written it as minus 3. So far so good. Take 3 common. I get x square minus 1, which is nothing but the p value. So right here, dq by dx is coming as 3p. Option is B. Option is B. Simple, very simple. Okay. Just you have to find the determinant, differentiate that because they're asking you the derivative of q with respect to x, and then move on to question number 8. The function fx is given as gif of x, greatest integer function of x. Continuous. No sir, no sir, no sir. It means option B is correct. How can you say that? Definition of GIF is what? It is that it is only continuous at non-integral value. At integral value, the limit does not exist. For all x belongs to integers, limit does not exist for what? For this function. For this function, limit does not exist. If limit does not exist, it means what? It means continuity cannot be there at those points, right? So that is the case. We can say the function is continuous at only non-integral values. Is minus 2 an integer? Yes. 4 an integer? Yes. 1 an integer? Yes. Means at 1, 4 and minus 2, the function is discontinuous. So continuous at which point? Option B, which is minus 1.5, which is not an integer, Question number 8 is done. 9th now, question number 9. Okay. X power y e power x minus y derivative is what? This kind of question what we do? We simply use logs on both sides. I've taught you this. Whenever you have powers in the given function. This is the implicit function form, and also there's a power. Apply log on both sides, then you take the derivative. Okay. So I'll apply here log x power y. I'm writing here log, but it means actually ln, okay? So I hope you know that. I've told you guys already many times. Here in our syllabus, log means ln only for boards especially, even for CET also. If you want, you can write ln also in your mind, but you can write log, works. If it is base 10, you can write that base 10 or any other base which is there. So the rule will say becomes coefficient, this whole thing. Right here, I have y log x equals to, what I get for this part? I get x minus y and log e. Log e is nothing but 1. Okay. Now differentiate this. Y derivative is simply y1. Y derivative is simply y1 and log x as it is. Plus sign will come. Differentiate now log. So I get y as it is. Log x derivative is 1 by x. So y by x. I have used the product rule, nothing else. Okay. About this side, derivative of x is going to be what? 1. And for y, what I'll have? For y, I will have here simply minus y1. Simply minus y1. All right. So let's do one thing. Move on this side, I get y1, a common log x. Okay. This moves over here, so becomes plus 1. I am moving this y1 on this side. Okay. And taking y1 common. And what about this? 1 minus y upon x. 1 minus y upon x. Okay. Now wait. I can find y upon x value from here, from this. Check this out. I have y log x. I'm writing this statement again. Y log x equals to x minus y. Because we have log e which is 1. So y log x is x minus y. Move the y on this side. I get y common log x plus 1 equals to x. Getting it? I'm moving this y over here. So it becomes y log x plus y. I've taken y common. Okay. Now move x on this side and this term on this side. So I get y upon x equals to 1 upon log of x plus 1. That's the value of your y upon x. simply substitute that over here. Simply substitute that over here. Have a look. So this term will become what? Y1 equals to, Y1 times we have log of x plus 1 equals to 1 minus 1 upon log of x plus 1. Log of x plus 1. If you take LCM of that, no, this will become what? Log of x plus 1 minus 1 divided by log of x plus 1. 1 and 1 is cancelled. Plus 1 minus 1 is cancelled. Last step. Check this out. I am writing value for y1. Okay. What is this left now? Numerator is simply log x. What about denominator? This log x plus 1. And one more log x plus 1 from here also comes on this side. It will become whole square. The log x plus 1 on the side of y1 is multiplied. Comes here, becomes again division. So whole square. Answer will be option number C. Answer will be option number C. Again you might ask me, sir, such a long steps, I don't have that much time in the CT examination. What to do? So in this you have to do some steps. I'll tell you which ones. So of course this is a very familiar question, keeps coming all the time. But if I want to tell you steps that is required to solve, we have to do this step. This is my first step. Okay. And we need to do this step also. Second step we have to do. Alright. And second step you can do, second step you can do. Third one you can do this one. Third one you can do from here. Third. From here only you can see this step is not required. Fourth. So total is 4 steps required in this question. Step number 1 is this part, writing the function after applying the logarithms. Second is the derivative of the logarithm, that product rule and the other side. Okay. And third will be your getting the value of y by x, and fourth will be your this step. That is what is required. This you don't have to write. Okay. This you can get from here only. No. Y by x is equals to 1 upon log x plus 1. So 4 step question. Yes, 4 step, but you can solve it in, I think, within 1 minute. This will not take more than 1 minute if you know the procedure properly. Question number 10 now. Question number 10 now. Okay, this is a trick question. If you want, apply log on both sides. Apply log on both sides. It takes a lot of time, but calculate it. If you want, method one is simply apply log on both sides. Both sides you're going to get the result as y by x. Do it. Otherwise there's a hint, there's a trick to this. Whenever you have this kind of form, x power m y power n equals to x plus y power m plus n. Look carefully to the form. This basis over here gets added up, and this index over here again gets added up. Basis gets added up, index also gets added up. Whenever you have this kind of equation given to you, derivative of that function y will always be y by x. Always will be y by x. If you want to change that to x by y, it will become x by y. Okay. So this is a trick, very important. Remember this, and if you want, let me know in the comment section whether this method gives you the same answer or not. This is method number 2, the trick. For this one, dy by dx will always be y by x. Okay, that's the trick. This is the trick, short trick. If this form suits this form, means answer is y by x directly. No need to do anything. But the method 1 is take log on both sides, keep differentiating. It will take half a page of derivatives. I think 5 to 6 steps it will take, and then you can get the answer as same option D. Just comment below whether you verified it or not. Comment below that it is verified, sir. It is verified. Check once, it will come like this, my guarantee. Guarantee it will come like this. Okay, please check once. Question number 10. For your own confidence, to trust in this method. Look, if I give you this method without this method number 1, you might not trust this. You might forget this. But if you do this method 1, do this approach, get the same answer, and you want a quicker result, you want to save some time, then you remember the trick. Okay, so method 1 is important, but method 2 is faster, of course, much faster. Question number 10 is done. 11 now. Tan inverse of x square plus y square equals to alpha. Find the dv by dx. Okay, tan inverse x square plus y square equals to alpha. Tell me what actually you think of this. Of course, take tan inverse on this side, sir. Take tan inverse on this side, sir. It will become simply tan alpha, which is a constant. So I get x square plus y square equals to tan alpha. Something like, remember what is this equation of? A circle. Okay, something like this. Okay, where the radius is root of tan alpha. Okay, so now you're going to differentiate this. You'll have 2x. For this you'll have 2y, y1 equals to 0. Correct? Derivative of x square is 2x, derivative of y square is 2y, but derivative of y will be y1. So remove this 2 from here, we don't need that, and we get y1 equals to minus x. So I get y1 equals to question number 11, option A is correct. Question number 11, option A is correct. Very simple question. Again, one step problem. This is the only step which is required. Step is only one. This is the only one step problem. Question number 12 now. Y equal to tan inverse of sin x plus cos x minus sin x. Find the derivative then. Okay, very simple. You can see where we have here tan inverse. We have here tan inverse. How do we get rid of tan inverse? How do we get rid of tan inverse? We should have, sir, tan over here. We have sin cos, but we can convert that into terms of tan. Let's make that work. Tan inverse, divide that by cos, we get here tan of x, we get here 1, and we get here 1 minus tan of x. 1 minus tan of x. Divide everything by cos, you get sin by cos is 1, cos by cos is 1, and sin by cos is of course tan. There is a formula for this, if you remember. Yes, the formula is tan of pi by 4 plus x. Sorry, yeah, tan by pi by 4 plus x. That's the formula. Operate this. You'll get the answer as simply pi by 4 plus x as the function. You're looking for what? You're looking for derivative. So 0 plus 1. Answer is what? 1. Answer is what? Option D, which is 1. Do you feel it's a simple question? Do all of you feel this is a simple question? Because it is simple. And where is this question coming from? CET PYQ of the year 2017. Check this out. CET PYQ of 2017. So of course questions like this can come and you can score easy 1 mark. Easy 1 mark. 12th is done. 13th now. For a constant, again for this question I'll give you a trick. If you want, you can solve this entire problem or check from the options. That's the trick over here. Entire problem means that, see, over here no problem, these terms no problem, but x power x, yes, that is the problem. If I take this function to be, let's say, t, if I take the function x power x as t, I have to use log on both sides to solve this question. It will become x log x and log t. Then you're going to solve this. You'll have this as log of x plus 1 equals to 1 upon t, and we'll have of course t dash or t1. Got it? So like that you'll have, and if you take on this side, you'll get what? T times of 1 plus log x equals to t dash. Check this out. 1 plus log x into x power x. So you have that coming everywhere, right? So this is required in the question. This is required in the question, of course. But lucky for us, in all the steps, in all the options, they have given that common. Check. In option A, B, C, D. Isn't that common? X power x 1 plus log x, x power x 1 plus log x. All option has that. It means that is the derivative of this term x power x. So why do you find that? Why would you find that if it is already given? There is no marks for step marking over here. Only quick answers and correct answers. Quick means save some time, correct means 1 mark. Okay, so we don't have to do all of this. If this question comes in examination, you will not have to do the entire procedure of getting this done. What are you going to do rather? It's a constant, sir. This is a constant. A power a means derivative will be 0. A power a is a constant. Derivative is 0. a power x, sir. A power x derivative is what, dear? We have a power x ln a. That's the derivative of this. Derivative of constant is 0, excuse me, and derivative of x power a is nothing but a x power a minus 1. So look for these options: a x power a minus 1, ax log a, and this 0 is of course here added plus 0. In this case, ax log a is missing. Here something else is given, some weird thing. Option C and option D. It means my option B is the right choice. So you can solve this question within 5 seconds. Within 5 seconds, because it's a formula, right? X power a derivative is a formula. You know the formula: a times of x power a minus 1. 1 second. A power x formula again, a power x ln a. So you can see here the two results are given. Constant will be always 0. 5 seconds it took us to get the answer to option B. Why 5 seconds? Because we don't have to check the derivative of x power x. It's common given over here. We don't have to identify whether it is plus or minus or negative, whichever is right one. If they would have given here minus sign or somewhere like this, then you have to do this step. Then you have to do this step. Is that crystal clear? All of you, answer me. Is that clear? Do you like this method? Do you like this trick of getting the result with the help of the options given to you? Please try to save time using all these things. What happens is you generally rely on me to give you a lot of tricks. Sir, every question you give tricks. 60 questions, 60 tricks, sir, question is solved in, the whole paper is done in half an hour. It does not work like that. It does not work like that. You have to use tricks of elimination method. Which option is wrong? What are the minimum number of steps required to solve a question? By learning the entire concept, that's the right approach. Okay. Question number 13 is over. Question number 14 now. And do not forget to download this class note and practice all the questions. Very high weighted chapter and the first chapter of your calculus of PU2. You must solve all the questions. You must. Okay. So download the class notes. You have joined the WhatsApp channel. From there you're going to get the class notes. Download and solve all these questions again. Until when you are comfortable solving all the questions the way I am. Right? That's the end goal. 14th one. Fx is cos x minus sin x. Looking for derivative at pi by 6. Now for some student, again there will be, sir, how will I open the mod? Or looking at mod and derivative at pi by 6, I'll leave the question. I'll tell you what, if I was a student, I'll do that. Sir, mod is there, I'll come back to the question later. I'll tell you what, very simple, draw the graph. Trick of this question is draw the graph. Sin x is this, sin x, yeah. Cos x is this, which point is this? 45 degrees. This point is 45 degrees or pi by 4. The common point is 45 degrees or pi by 4. What is this angle? Pi by 6. This means what? At what degree? 30 degree. 30 degree will be somewhere over here, right? This is my pi by 6 or 30 degree. Add that, this function is what? Cos. And this function is what? Sin. Think carefully. Add pi by 6. Isn't cos more than sin? It is. It is more than sin. It means, of course, this bracket, this modulus will open with the plus sign only, no sir. It means fx will not be modulus, it will be simply cos x minus sin x. Because mod will open with the plus sign, because cos is more. This value here is positive. Cos is more than sin. It means the value difference of cos minus sin is positive. So it will open with the plus sign. Okay. Now differentiate. We get this as minus sin x. This will be again minus cos x. Okay. Take minus sin common, you get sin x plus cos x. Sin x value at pi by 6. Sin x value at pi by 6. So sin pi by 6 plus cos pi by 6. Answer here 1 by 2. This is root 3 by 2. What is the answer going to be? Minus 1 plus root 3 by 2. Minus 1 plus root 3 by 2. So your only goal was to identify this graphical part. If the graphs are clear, your results is very much simple to you. Now if you are thinking for 1 second also, sir, why are you taking pi by 6 cos minus sin? Because cos derivative will be sin actually, it will become sin minus cos. Do not think for the sign of derivatives. Do not think, if somebody, even one of you are thinking this way, that sir, derivative sign will look for, no, because this is derivative of pi by 6. So derivative of pi by 6 they are asking. Then why are you looking for the sign of fx? You should look for the sign of what? Sign of actually f dash. No, because modulus is applied to the function, not the derivative. The modulus which is given to you is applied to the function. So we have to check the sign of the modulus for the function only, not the derivative. This is clear. That's why I have drawn the graph here. Cos is this one, sine is this graph, and at the pi by 6 cos is more. At x equals to pi by 6, cos x of course is more than sin x. So cos minus sin is positive. Hence cos minus sin is positive. I can open the modulus with the plus sign. Differentiate is easy now. Minus sin and sin becomes cos. We have 2 minus sin, take it outside. Sin pi by 6 and cos pi by 6 is 1 by 2 plus root 3 by 2. Answer is 1 plus root 3 by 2. Option A is correct. Option A is correct. Okay. This is a very good question. This is a very good question. Steps required over here. This, yeah, draw the graph. Okay, one step is important. Again, this step is required. Step number 2. And that's all. This is good enough. So only 2-step problem. Graph, whatever time it takes, draw that. So again, this question will take you 60 seconds, not more than that. Even less will be good enough, but not more. Okay. With practice, 60 seconds is good enough to solve this question number 14 also. Question number 15 now. Y equals to root of x plus root of x plus root of x till infinite number of times. Do one thing. From this infinite number of x's, remove one x out. From this infinite number of x plus root x, remove one x out, one root x out. What is remaining? Same thing, no? From infinite number of x root plus x like this, what we have? Same thing will be left if you remove one thing from infinite. If you remove one from the infinite, if you remove one, what is remaining? Infinite only, right? So that is nothing but your y. That is nothing but your y only. Now square it up. Y square equals to x plus y. Differentiate now. You get 2y, y1 equals to 1 plus y1. Move on this side. I get 2y, y1 minus y1 equal to 1. y1 is common. 2y minus 1 equal to 1. So y1 is nothing but 1 upon 2y minus 1. Option D is correct. Is it simple or not? So here the step which is required over here, step 1, step 2, and yeah, this step. I think that's all. Step 3. Okay, step 4 also. Yes, this might require 4 steps, but all are very simple. Even though you might require 4 steps to solve this question, but in your mind you can do all these steps. Simple calculations. So 4 step but 30-second question, not more than that. 30 seconds also is too much. 15 to 20-second question is this, question number 15. Question number 16 now. Okay. Alright, so log of this is given, log, so ln x upon x minus 1 is given, continuous they have given, okay. Continuous at the point x equals to 1. Limit of the function fx, x tends to 1 is nothing but f of 1. Limit will be used over here. So limit log with the base e means ln. So ln x upon x minus 1. This is x tends to 1. F of 1 is how much? K. Right here k. F of 1 is k. Differentiate. Use LH rule. Use LH rule for the limit part. Differentiate under the limit. What I'm going to get? It will become 1 upon x, okay, upon 1 minus 0 equals to k. Again we have limit over here. Limit x tends to 1. What is the answer? 1 upon 1 upon 1 equals to k. Value of k is what? 1. Value of k is what? 1. So option B. Option C is actually minus 1. I hope this is clear. This is minus 1, okay. Option B is correct. Option B is correct. Option C was given as minus 1, okay. So I hope this is visible. Question number 17 now. Fx equals to sine inverse of 2x 2 power x plus 1 upon 1 plus 4 power x. Looking for derivative at the point 0. Okay. Sorry. Looking for f dash 0 equals to what? F dash of 0 equals to what? Okay. So let's solve it. F of x equals to sine inverse is there. I have to get sine inverse in this part. So write here as 2 times of 2 power x divided by 1 plus 2 power x the whole square. What I have done? Nothing. I have written the same thing in this format. 2 power of x plus 1 is there, no? I am taking 1 outside, okay? So it becomes 2 into 2 power x. Remember, product rule in the exponents. 2 into 1, 2 power into 2 power x becomes the sum of the index, 2 times of x plus 1. Now, next is substitution. Next is substitution, 2 power x as tan theta. 2 power x as tan theta, okay? Right here. Sine inverse of twice of tan theta, okay, upon 1 plus tan square theta. Now this here is nothing but formula for sine 2 theta. All of you should know this. The formula of sine 2 theta is in terms of tan theta, 2 tan theta upon 1 plus tan square theta. Okay, fx equals to what I get from here? Simply 2 theta. If I am getting this 2 power x as tan theta, it means theta value is tan inverse of 2x. Sorry, tan inverse of 2 power x. Theta value is tan inverse of 2 power x from here only. Write that 2 times of tan inverse of 2 power x. This is my f of x. Differentiate now. 2 times of this 1 upon 1 plus 2 power x the whole square. Is it over? Is it over? No, sir. Differentiate 2 power x also, we get 2 power x, okay, and ln 2 and ln 2. Have a look. So we get here 2 times of ln 2 and 2 power x, of course, okay, divided by 1 plus 2 power x the whole square. We have here f dash of x, okay. Now replace this with 0, x with 0. Wherever we have x, no, we can replace that with 0. You'll see. 1 second. F dash of 0 we are looking for, right? So right here 2 power 0, 2 power 0. What I'm getting? Have a look. 2 times of ln 2. 2 power 0 is what? 1, and 1 plus 2 power 0 is what? Again 1. 1 square will be 1 only. What I'm getting? This 2 will cancel this 1 plus 1. My answer is what? ln 2. My answer is ln 2 or log 2. Option C is correct. Option C is correct. Okay. Option C is correct. Question number 18 now. If x equals to a sec square theta, y equals to a tan square theta, what's the second derivative of y with respect to x? Second derivative of y with respect to x. Let's do that. Difficult? Of course not. Differentiate this. We'll have the parametric form. Differentiate y with theta. What do we get? A 2 times of tan theta, okay, and differentiate. So far we have done derivative of polynomial function. Polynomial form is tan square. We have done that 2 tan theta, okay. Next will be trigonometric function. Derivative of tan will become sec square theta. That is it. Next step. What is it? Differentiate this x with respect to the variable theta. Again a comes, polynomial function 2 sec theta. So far we have done for polynomial of sec square, comes as 2 sec theta. Next will be derivative of trigonometric function, which is going to be sec theta tan theta. Sec theta tan theta, okay. Cross check. 2 a cancel, sec and sec cancels, tan and tan cancels. So my dy by dx is coming as 1. So d square y will be 0. Constant derivative is 0. Option is B. Option B is correct. Okay. 18th is done. Option B is correct. 19th now. 18th is clear. 19th now. Okay. Alright, how do you solve this question? Same thing, they have given us continuous. They have given us continuous. It means that we can apply a limit and the same approach of the function value should be equal. So right here, limit of the function given here as sine 3x is there, no, first. We have first as sine 3x, excuse me. 1 second, sir. Sine 3x upon e power 2x minus 1 when x tends to 0 equals to k minus 2. Basically f of 0, right? F of 0 is k minus 2. F of 0 is k minus 2. Okay. Same thing, apply LH rule, apply L'Hopital's rule. What are you going to get for this? You will have sine 3x as cos 3x, okay, and derivative of 3x will become what? Simply 3, and for e power 2x we will have what? 2 times of e power 2x, 2 times of e power 2x. For 1 will be 0, right? So 2 times of e power 2x, of course minus 0 is there, equals to k minus 2 as it is, limit continues x to 0. Okay, substitute now, we get cos of 0 times of 3, and we have twice of e power 0. Last step, cos 0 is 1, so 3 by 2 I get. Cos 0 is 1, e power 0 will be again 1. Cos 0 is 1, e power 0 is also 1. 3 by 2 equals to k minus 2. So k will be 2 plus 3 by 2. How much is this? 7 by 2. K value is D. Moving to question number 20. Question number 20 now. Question number 20. Similar question, let's solve this as homework for all of you. This is your homework, solve it and comment your answer. Comment, answer. Okay, same thing, continuous, they have given us at point x equals to 0, so limit will be equal to what? The function value at 0, solve it and give me the answer. Download the class notes, if you want you can pause it over here, solve and give me the answer in the comment section right now. Okay, 21. We have done this question right now, haven't we? Right, take x as tan theta. Sine inverse of 2x upon 1 plus x square is given. There is a formula for this in terms of tan. So right here, f of x equals to sine inverse of 2 tan theta upon 1 plus tan square theta is nothing but sine inverse of sine 2 theta, nothing but 2 theta is the value of f of x. From here you can get theta value is nothing but tan inverse of x. Tan inverse of x is the value of theta from here, from the assumption. I have taken x equals to tan theta, right? From there we get theta as tan inverse of x. Okay. So fx equals to 2 times of tan inverse of x. So f dash of x will become twice of, derivative of this will be 1 upon 1 plus x square, okay, and we are looking for f, so will become 2 upon 1 plus x square. I am looking for f dash when x is equal to root 3, so 2 upon 1 plus root 3 square, so 2 upon 1 plus 3, 2 upon 4, 1 by 2 is the answer. 2 upon 4, which is 1 by 2 is the answer. Option A is correct. Question number 21, option A is correct. Okay, all of you agree? Yes? Yes? Alright. Now question number 22. Question number 22. A very interesting question, simple but interesting. Okay, I'll show you how. First of all, I would like you to try once. So please pause the video over here and give an attempt from your side, then come back and check the solutions. Try. Once all of you try. Question number 22, given as 2 power x plus 2 power y equals to 2 power x plus y. Solve it, come on. Okay. How do you solve this, sir? How do you solve this, sir? Differentiate on both sides. ln 2 2 power x plus ln 2 2 power y y1, right? And over here x plus y, sorry, 1 second, my mistake. 2 power x plus y actually, 2 power x plus y ln 2, and of course derivative of this will be also there, so 1 plus y1, 1 plus y1, ln 2 is cancelled. What I'm getting here, 2 power x plus 2 power y, y1 equals to 2 power x plus y, 1 plus y1. Derivative of x plus y is 1 plus y1. Now separate the y1 terms. So I'm getting here 2 power y, y1 minus 2 power x plus y times y1 equals to 2 power x plus y minus 2x. Minus 2x. Take y1 common over here. I get 2 power y minus 2 power x plus y, and over here I get 2 power x plus y minus 2 power x. Check this out. 2 power x plus y value they have given over here. Okay, so we'll put that back once again in both the places. Okay, in both the places. Just be careful over here. y1 times of 2 power y remains as it is, minus this will be replaced. I get 2 power x plus 2 power y. This is done, equal to, on the side again replace one more time, 2 power x plus 2 power y minus 2 power x. This and this is cancelled. Over here we have this and this is cancelled. I get y1 equals to, so y1 times of minus 2 power x equals to 2 power y. I get y1 equals to minus 2 power y divided by 2 power x. This minus sign over here is been taken on this side. Okay, clear? So I get y1 equals to minus 2 power y minus x. That's my answer. This x will become difference in the index, right? Difference in the index because the base is same. Quotient rule of derivatives, sorry, exponents. Option A is correct. Option A is correct. Alright, option A is correct. That's why I said interesting question, because we are using this once again. 2 power x plus y, 2 power x plus y, both the places. We have to substitute once again. 22 is done. Question number 23. 22 was easy. Yeah. This one is even easier. Okay, this is your homework. Try this. Homework and comment your answer. I want all of you to comment your answer very seriously. Not a joke. I want your answers for sure. All of you who are watching the videos, I want the answers when I ask you for any particular question. Okay? It shows the engagement. It shows that how much actually you are able to understand the concepts or what troubles you are facing. I want those answers for sure. So this one is simple. That's why, because I've given here, what are you going to do for this question? Apply logs on both sides. Apply logs on both sides and then simplify. You'll get the answer. Very simple one. Okay? And similar to this we have done. We have done similar to this. That's why I've given it over here. 23 is done. 24 now. Don't forget me to give the answer for question number 23. 24. Y equal to 2 times of x power n plus 1 plus 3 upon x power n. Okay. Let me rewrite this once. Y equals to 2 times of x power n plus 1 plus 3 times of x power minus n. It will be easier for us. What are they asking? They are asking us x square times of second derivative of y with x. So let's find second derivative first, then we're going to multiply x square to that. Okay. So first finding first derivative, I get y1 equals to 2 as it is. This n plus 1 will come in front as the coefficient, and x power n. The formula you remember for polynomial function, same I've used over here. This will become what? Minus 3 times of n, x power minus n minus 1. Correct? So this minus n comes in front, that's why it becomes minus 3n and minus n minus 1. One more time, y2. Second derivative. What I get for this one? Have a look. So I get 2 times of n plus 1, and we have one more time, n comes here, comes here, x power n minus 1, and for this what I get? Minus 3 is there, and we get minus n minus 1, okay, with of course n, x power minus n minus 2. Look, this n was already there, okay, and this thing comes over here. Just writing, okay, you'll see. Now next step, very carefully, we'll make the sign changes. Have a look. 2 times of n plus 1. Rewriting this, I get x power n minus 1. Okay, and minus sign, I'm taking this minus sign outside, it will become plus. So 3n n plus 1 x power minus n minus 2. So we have got the value of y2. Are they asking us y2? No, they are asking us x square times of y2. Let's do that. X square y2. Multiply x square everywhere. Will you multiply to this 2n? Of course not. So actually I can take something common over here, no? N times of n plus 1, n times of n plus 1. Let's do that first. Let me simplify one more time. Simplify this one more time. So I get y2 equals to n times of n plus 1, and over here we have 2 times of x power n minus 1 plus 3 times of x power minus n minus 2. Is that clear? I have taken n times of n plus 1 outside the bracket as common. Now I'm going to multiply x square y2. Again same thing is common over here. Multiply it inside, 2 times of x square x power n minus 1 plus 3 times of x power minus n minus 2, again x square. You have to multiply that to both the terms, right? Multiply that to both the terms. Okay. I think by now you must have got the answer. Yes. You can see option is coming as option A. Check this out. X square y2, n times of n plus 1 is there, of course. We have here same base power has to be added, so I get n minus 1 plus 2. Comes here plus sign, same thing, same base power has to be added, minus n minus 2 plus 2. Check this out. Minus 2 plus 2 gets cancelled. Here we get this result as equal to 1. My answer is coming as n times of n plus 1, and this is nothing but 2 times of x power n plus 1. This is the same term. 2 times of x power n plus 1, and this is 3 times of x power minus n. Same term. So into y. That's my answer for x square y2. Please cross check. If you're not sure, pause the video, watch the entire steps, or watch it again couple of times if you have to. It's very, very important. Watch it again if you have to. PYQ from 2020. This is clear? Okay, answer is option A. Question number 25 now. If A and B are fixed non-zero constants, then the derivative of this thing, A upon x power 4 minus B upon x square plus cos x derivative is coming something as this. We'll see that later. Let's differentiate first. Differentiate this, we get what? A times of minus 4, because this will go up, right? X power minus 4. X power minus 4 will become, so minus 4, and we'll have x power minus 4 minus 1, which is minus 5, so x power 5 comes here. All of you know how to differentiate polynomial function. Same thing I've done over here. You have x power minus 4, differentiate this. What are you going to get? You'll have this as minus 4x power minus 5. That is what I've written over here. Minus 4 upon x power 5. Same thing, this will become plus sign. You'll have over here 2b upon x cube. This will become minus sin x. Now compare. Compare this with ma. So you got what you are getting over here, minus 4 upon x power 5a plus 2 by x cube upon b minus what you have, sin x. If you compare now, you're getting value of m as minus 4 by x power 5. This is correct. N as 2 by x cube. This is correct. So we have only one option like this. Option B is right. You can check here, it's coming. Sin x is same as p. Option is right. This is clear. Question 25, option B is correct. Differentiate this and compare to get the terms value of m, n and p. M, n and p. Clear? Let's move on next. Let's move on to next question. Okay. So question number 26, have a look. At x equals to 1, the function fx equals to x cube minus 1 and x minus 1 from 1 to infinity and minus infinity to 1 should be continuous differentiable what? Let's check. We can Let's check for continuity. I think it's continuous only. If you check over here, what are you going to get? Find the limit value at the point 1. Limit value at the point 1. So limit will become what? We can check from this side. You'll have x cube minus 1 when x tends to 1, right? When x tends to 1, it becomes simply equals to 1 cube minus 1, which is 0. And what about the value of the function? If I ask for f of 1, this will be taken from this part. So I get x minus 1, it will be 1 minus 1, so 0. So I'm getting the limit and the function value is same. The limit and the function value is same, therefore continuous. Continuous. The limit value and the function value at the point x equals to 1 is exactly same as 0. It means the function is continuous. What about differentiability? Again, same thing. Find the derivative over here. For both the sides, LHD will come from here. So you get this as 3x square, and from here you're going to get 1. Okay? And if you apply the same conditions, 1 less than x till infinity and x less than equal to 1, what do you get? So your LHD is coming as 1, whereas your RHD is coming as 3. Put the value of 1 at the point 3x square, you get the value as 3. So you can see here LHD is not equals to RHD. The left hand derivative and right hand derivative is not equal, it means non-differentiable. So answer will be option B. Answer will be option B. It's again a PYQ from 2020. Let's move on to question number 27. This was clear, right? This was clear very much. Okay. So question number 27 now. Again another PYQ from year 2021. It says we have y equals to cos x square the whole square, find the derivative. A very, very simple question. Just follow the chain rule properly. If you can see that through, your answer will be exactly correct and in one step. Differentiate. So we have y, I'm going to write here y dash directly, y is given over here. I'll write directly as y square, sorry y dash. I'm going to write directly as y dash. Okay. So let's continue for y dash. What we are getting? Check. We'll differentiate first for polynomial function. Whenever you see powers are there, no? Whenever you see there's a power, whether it is to inverse or it is to log, it is to trigonometric function, whatever is function over here present, but if you have powers, power 2, power 3, even if it is root, then what happens is first function is not the function given to you, actually it is the polynomial function. Okay, so let's apply that, because this can be taken as, no, if I take cos of x square to be a function t, then the given function is y equals to t square, right? Then if you differentiate this part, no, you end up with 2t. You end up with 2t, right? So same fashion, if you do it over here, I can write 2 times of cos x square as my first function's derivative. First function's derivative. Is it over? Of course not. I have 2 more functions to deal with in this chain rule. Next is the cos function. First was this. Second is the cos. So cos will become what? Minus sin x square. Is it over? Still not over, sir, because still we have to deal with the x square. Okay. So derivative of x square is going to be what? 2x. Derivative of x square is going to be what? 2x. Now have a look. Right here 2x outside minus 2x. This minus sign will present over here and this 2x kept as it is. Write together 2 sin x square cos x square. I know all of you know how I have written this step, right? This becomes minus 2x and sine of 2x square. That's my answer. The sine 2a formula, 2 sine a cos a. In this case, the a value is x square, so 2 sine a cos a becomes sine 2a, so 2x square. Option is C. Excuse me. Option is C. Question 27. Option C is the correct one. Let's move on to question number 28 now. This is very simple. One step problem was the previous one, 28th one. Okay, over here, this is not at all difficult, but little bit calculative, and you have to be very careful in the calculation. Because what happens, no, usually in the simple calculations, we try to be faster and keep making mistakes over there. So I don't want you to do that. Please avoid that mistakes. Okay, so we have 3 functions here, 1, 2 and 3. Do we have 3 functions? Yes, we do. Okay, we don't have 1 function, we have 3 functions, and they're all in product. So I have to apply product rule. Excellent. Let's start from here. Y dash. I'm going to differentiate. I've learned that in product rule, I'm going to differentiate one by one each of the function, keeping other two as it is. Okay. So I'm going to differentiate the first function twice of x minus 1 and other one as it is. X minus 2 the whole cube, x minus 3 the whole power 5. Plus sign will come. Plus sign will come. This time differentiate the second function. So for that I'll have what dear? I'll have 3 times of x minus 2 the whole square. Differentiation of this, okay? 3 times of x minus 2 the whole square and keeping the other two function as it is, which is x minus 1 the whole square and x minus 3 from here the whole power 5. Again we have a plus sign. Okay, again we have a plus sign. Last time we're going to differentiate this last function. So we'll have 5 times of x minus 3 the power 4 actually. I wrote 5 by mistake. Okay, so this is nothing but 4 actually. Okay, derivative of this and the other two remains as it is. So I get x minus 1 the whole square and x minus 2 the whole cube. Okay, now the function we already have. I'm looking for derivative when x is 4. Derivative when? So right here y dash when x equals to 4. That's how we represent it. Y dash when x equals to 4. That's how we write it. Okay, derivative at x equals to 4. Substitute. I get twice of 4 minus 1. How much is 4 minus 1? Simply 3. And this one 4 minus 2 will be 2 cube. This one 4 minus 3 will be 1 power 5. Same. Continue for this part. We'll have, please check for this part carefully. For the second term we'll have 3 times of 4 minus 2 again. So 2 square, 4 minus 1, so 3 square and 4 minus 3 which is 1 power 5. If I have made any mistake in this calculation part, you have to let me know in the comment section. Okay, usually I have not tried to make any, but if I have, you have to tell me. 5 times of same thing, 4 minus 3 which is 1 power 4, 4 minus 1 which is 3 power 2 and 4 minus 2 which is 2 power 3. Alright, let me continue. Y dash when x equals to 4. Check this out. This is 8 into 3 which is 24 into 2. So 48. First term's value is 48. Over here 1 power 5 is 1 only. I am ignoring that. Okay, 3 square is 9 and 9 into what do we have over here? 8, sorry 4 into 3, 12. 12 nines are correct now. This is 4, 2 square is 4, 4 into 3 is 12, 12 into 9 is 108. 12 nines are 108. The last one 5 into 8, these two combination, 2 cube is 8, so 5 into 8 is 40, 40 into 9, 360. If you are not sure with my way of calculation, please try your own way and get back the answer if it is same or not. Okay, we'll cross check. So I'm getting the answers from here, please check. My answer is coming as 8 plus 8 is 6 and then we get carry is 1. Okay, so 7 and they get here 7 fours are again 7 plus 4 is 11, 3 plus 1 is 4 and 5. 516 is my answer, which is option number D. I told you a little bit calculative but not at all difficult. I have taken my time to solve it, but you can solve it faster. Okay, you can solve it faster, but this will be a little calculative, so it will take at least 1 minute to solve. You have to you can start solving from here only if you want. You don't have to write this step. If you can, if you know, because this is very simple derivative. Okay, so you can ignore this step, this can be ignored. Just write this step as step number 1 and step number 2 as the correct steps. This is not required. Okay, this step is not required. All right, let's move on. Let us move on then. Question number 29. Previous one is answer as 516. Download the class notes in the PDF format from the WhatsApp channel to practice all these problems once again. It is a must. I'm telling you. You all were asking me in the previous live how to make a difference, sir. What is the strategy for CET, sir? Follow the content, practice the content. You know, be comfortable in all these questions. All the PYQs that you're solving, you should be able to solve the questions effortlessly. When I say effortless, it doesn't mean that you have memorized the question and then you are getting the answers. No, it means the concept behind the problems, you are comfortable with that and hence you get the answers easily. If that much you can do for every single sum in the PYQs of mathematics, for chemistry, for biology, for physics, it means your preparation is going exactly how it should go. because PYQs are the question that they have asked, similar to what, of course not the same question, but similar to what will be expected this year as well. Might be difficult, might be easy, but it will be the same for everyone. So please follow my word. PYQs, you should be extremely comfortable, and comfort of what kind? Not the memory kind, actually the concept kind. Question number 29 now. Y equals to, this is given, okay, finding derivative, very simple, y dash, find it here. Derivative, I am going to differentiate this part, so I get 2x, this remains as it is, tan inverse of x, okay. I am using the product rule, differentiated this part, kept this as it is. Next, what is going to be there? Plus this as it is, 1 plus x square as it is, differentiate tan inverse, you are going to get 1 upon 1 plus x square, derivative of tan inverse, and derivative of x will become 1, it will become 1, have a look. This and this is cancelled, okay. So I have here 2x tan inverse of x plus 1 minus 1, this is becoming plus 1, this is becoming minus 1, cancelled. My answer is 2x tan inverse of x. Option A is correct. Option A is correct. Question number 30 now. This was very simple, extremely simple. Okay. Y equal to cos x upon 1 plus sin x. Now this is a good question, PYQ from 2025. This year's PYQ of KCET. Okay. Let's differentiate them. We have to choose the correct options, and maybe more than one option is also correct. Okay. Let's see. So we're going to differentiate this first, this part first. Y dash becomes equals to quotient rule. So we get minus sin x numerator, keeping 1 plus sin x denominator as it is. Next comes the minus sign, keep the numerator cos x as it is, and differentiate the denominator. I get 1 and sin x derivative as 0 and cos, 0 plus cos x, okay, divided by denominator the whole square. That's the rule of quotient derivative, okay. Simplify this, I'm getting here y dash equals to, check this out, minus sin x, and I get minus sin square x, and I'm getting here minus cos square x, okay, divided by 1 plus sin x the whole square. Check this out, this 2 will make what? This 2 will make actually minus 1. If you take minus sign common, right, if I take minus sign common from here, what I'm getting, please check. I'm getting in the numerator sin x plus, this will become what? Sin square plus cos square. So 1 divided by 1 plus sin x the whole square. I have same numerator denominator with 1 extra in the denominator term, which is 1 plus sin x. Remove that. My answer of derivative is coming as, y dash is coming as minus 1 upon 1 plus sin x, 1 plus sin x. Now looking at this, we'll get the answer is correct, sir, option 1. Very good. Only one is correct, option B we will choose and will be wrong. Option B we will choose and option B will be wrong, because actually we still have one more correct choice. We still have one more correct choice. Please check. If you are smart, if you are thinking that way, okay, then question 1, option 1 is fixed with 3, means try to check 3. Will you check option 4 or 2? Will you check option 2 or 4? You should not check option 2 and 4, because either my answer is B, which is only one option is correct, or the option which has option 1 in it, correct? No, the option which has 1 in it. So option 1 is present in either B or C, correct? And C has the other one as 3. So do not check second and fourth one. Second one is of course wrong, right? So check the third one. You can check the third one, and if we get the third one correct, means C is the right option. If you don't get third one correct, means we'll move on to the option B. I hope this is clear how to pick the options to verify. Why would you verify all the options? Okay. So far I have minus 1 upon 1 plus sin x. So see here, you want to get sec square. It means you need to make this as cos. You need to make this as cos. Now actually right now 1 plus, if it was cos, if it was 1 plus cos, then I would have, got that something like that can come. 1 plus cos will give me a result. You can actually try that. I'll give you a method. Try this. Write sine as cos of pi by 2 minus x. Pi by 2 minus x. I can replace this with 1 plus cos of pi by 2 minus x. Okay, I'll show you over here. So far I have y dash equals to minus 1 upon 1 plus cos of pi by 2 minus x. Okay, writing sign as cos pi by 2 minus x. Continue, minus 1 upon, what I get for this? 2, formula 1 plus cos formula, remember 1 plus cos theta is nothing but 2 cos square theta by 2. 2 cos square theta by 2, that's my formula actually. Check this out, it will become 2 cos square, okay, and the angle by 2. So pi by 2 minus x, the whole thing divided by 2. So this will become what, dear? Minus 1 upon 2, the constant, and I have over here cos square, okay, and this will become what? Pi by 4 minus x by 2. Have a look. Minus 1 by 2, I get now cos square is in denominator, it will go up sec square pi by 4 minus x by 2. Now this is option number 3. Minus 1 by 2 sec square pi by 4 minus x by 2. 1 by 2 sec square pi by 4 minus x by 2. Now there can be more than one method to reach this conclusion. Okay, there can be more than one method to reach this conclusion. You can use the other method also, but this is one of them, and I find this is easier. Okay, simply you have to check, because logic says that the question has sec square in it, the option has sec square in it. So I have to make this something in terms of cos. 1 by cos will become sine, but I can make this cos easily if it was 1 plus cos. It is not 1 plus cos, it is actually 1 plus sine. How do you convert sine into cos? Using this very formula. Using this very formula, sine can be written as cos pi by 2 minus x, and that's what I did over here. That's what I did over there. Right? I got cos of pi by 2 minus x from there. 2 cos square pi by 2 minus x by the whole thing by 2, the angle divided pi by 4 minus x by 2, that becomes sec square. I hope this is clear. So now both options are actually true. I got this as my answer. I have simplified this to get even this as correct. It means my correct answer is option C. This is a very, very, very good question. Okay, this is a very, very good and important question. Why important? Because the board, the CET board, the examination KEA is asking you to think in this fashion. They are pushing you to think in this fashion. It means that this year's question paper may have a question like this in examination. I can guarantee that. This year's question paper may have a question based upon this category in maths especially. Okay, so this is little bit above what you expect in the examination, but this is a very good question. Please pay attention. Question number 30. Let me know if question number 30 is clear for everyone. Please give me an answer right now, comment right now whether question number 30 is clear or not in your mind. Okay, now 31. Again a very simple question, but you have to apply your learnings. Apply your learnings. We have column 1, it's a PYQ from 2025 this year. X times of mod x, so many functions are given. So one way is to find all the conditions, okay, and check which is the suitable option. Other way is keep finding the conditions over here and look for the options at the same time, which will be faster. I'll show you. This one, x mod x, what it means? It means, it has two meanings, sir. X into plus x, okay, or x into minus x, okay, which means I have either x square or minus x square. Draw the graph. X square is this, minus x square is this. Means when x is more than 0, when x is positive, when this is what? This is when x is positive. This is when x is more than 0. This is when x is less than 0. When x is positive, what happens there is the graph is plus x square. When x is negative, the graph is minus x square. Means this is the x square graph and minus x square graph. Now look at this graph. Is it continuous? Of course it is. Always continuous. It's a straight, it's a polynomial function kind of graph. Okay, it's actually looking like something of cubic function, but it's not cubic actually. But yeah, something like that it is there. So yes, continuous. Differentiable? Of course, sir. There's no break, there's no jerk, nowhere, no sharp corner. So we can see from here, option A gives me that it is actually coming out as differentiable. between what and what? Between the point minus 1 and 1. Don't worry about the domain over here, minus 1 and 1. Clearly option A is 2. Option A is 2, which is suitable one? 3. And your answer is 3. This is my answer then. See? You got my point? If you just see the option A is 2, in the options which is given to you 1, 4, 2, 3, I did not make this question, it's a PYQ. Okay? So option A is 2. It means answer is option number 3. But if you want to go ahead and find this one also, I'll show you, for example, this one. This root of x, mod means what? Means x has to be always positive. Mod means what? X has to be always positive. What it means here? It means this will be either, the root will be either plus x or minus root x. Don't worry about the domain right now. Do not worry about the domain right now. Think about this. Okay. Root x will look like this, right? Parabola, half parabola like this and half like this. X square equals to y. This is the root x part plus root x, and this is the minus root x part. Correct? Minus root x plus root x. Look at this. Sharp corner. Sharp corner. It means non-differentiable at one point. At one point, which is at the point 0. At the point 0. What is this? Not differentiable at least one point in the given domain minus 1 to 1. So for B option is 4. Check this out. Same you can apply to option C and D also. Same you can apply for option C and D also. Try for this question, write x as, what is x? Any function x is defined by your, the GIF part and your fractional part. Okay, you already have a GIF part, so this will become what? Twice of that and fractional part. What is fractional part? It's an increasing function like this. Okay, so graph will come always increasing for this part. The graph will come always increasing for this part. Okay, so you'll have this answer as strictly increasing. C will become equal to 3. C will be 3. Okay, because this is a constant, right? An integer value, constant value, but this will make always increasing function. If you remember the graph of fractional part, right? It was like this, no? Remember? Please go ahead and check the graph. Alright, and for this one, if you put the plus value, it will become x minus 1, x plus 1. Okay, so you're going to get from there 2x. Sorry, if you check for x minus, between minus 1 to 0, it will become 1 minus x actually, 1 minus x. Between minus 1 to 1, right? Yeah, so if you put minus 1 over here, this is always positive, of course. This is always positive. About this one, this will be always negative actually. If you put here even 1, it will become 0. If you put x as 1, it will become 0, otherwise it will be 1 minus x. So 1 minus x and x plus 1. What are you doing, sir? I am opening the modulus. In this given domain minus 1 to 1, what will happen to this? It will become 1 minus x and x plus 1. X plus 1 is always positive, so this is there. Check this out. X and x cancelled. I get 1 plus 1, which is 2. 1 plus 1 is 2. So it means basically my function over here is coming as y equal to 2. So it is what? It's continuous. Correct, always continuous. So for the fourth part, I am getting a straight line like this. This is x axis, y axis, and this is a straight line y equal to 2. Y equal to 2. This is my fourth option. Okay, so first option graph is this. This is my first options graph. This is A graph. This is the graph of B. This is the graph of C actually, and this is the D part over here. Explained to you. This is not the graph of D part. D part graph is going to be something different. It will not be like this actually. This is just the graph of fractional part. The D part graph will look like this actually. You will have this over here opens, and from here again it will be open like this. Okay, so you'll have the graph like this. 1 second. So you'll have the graph like this. Yeah, correct. Okay, so it'll be always an increasing graph actually. It'll be always an increasing graph. I have to draw the graph to test it. Fine, if you want me to draw the graph of this function, you let me know. But right now, use the graph of this one only. This one. This is good enough for us. Fractional part. Always increasing in nature. So you get the answer as 31. Option 3 is correct. This is my final answer. Okay. Option 3 is correct. Okay. Clear? A very, very good question. This is a question for toppers. This is a question for topper. So if you are able to get this question right, it means, give a pat to yourself. It means you are very much conceptually clear in the functions. If you are getting this question right, means you are very much conceptually clear in the function, but actually the board wants you to do what? The KEA wants you to do what? You have to figure out the first option only. If you get A equals to 2, option is correct, you get the answer correct in 10 seconds, 15 seconds. But if you want to get the entire part, let's say we had more than one, let's say here also 2, here also 2, I'll then move on to B, then I'll move on to C, like that. So do not have to do the entire thing to show the answer. You can just do the first part and get the answer. But I am a teacher, I have to explain all the options, that's why I have done all of this. Is that clear? Let me know right now. I know I am asking you to do too many things, but question number 31, clear sir. Question number 31, clear sir. Comment right now. Okay, this is clear. 32. Because if I am putting efforts, I want the efforts to come from all of you as well. Like you were all there in live sessions, even though it is a recorded session, you're watching it, right? I'm teaching you, then the effect should be the same, not less. Okay, come on. The function fx equals to e power x plus a power ax, and we have this over here for x less than 0 and x greater than 0. We're looking for what differentiable is given. It means it will be continuous also. So we need to make two equations, right? So we'll make one equation because we need to find the value of a and b, two variables. So for two variables we need two equations. One equation we'll get with the help of differentiability. Definition of differentiability is there, right? LHD and RHD are equal. For this we have LHD equals to RHD, and for this we have continuity limit equals to the function value at the point 0. Got it? So we have to do both the cases, limit equal to the function for the continuity part and differentiability. LHD and RHD are equal. From both of this we'll get two equations and we'll use that to solve and get our results for A and B. Let's start with the continuity right now. So if we have to do the limit on this only, please check, because f of 0 will become what? F of 0 will become b times of minus 1 square. How much is that? Simply b. F of 0 is b. F of 0 is coming out as b. Have a look. Clear? What about limit, sir? The limit of this part, e power x plus ax, when you take x tends to 0, you get this as e power 0 plus a into 0. What I get? 1. So I'm getting 1 as my limit value. Put them equal. So from here if I get what? This is equals to, this limit is equals to f of 0. Limit is equals to f of 0. It means it is equal to b, equal to b. It means my value of b is 1. Is this good enough? No, we have two options with, okay, three options with the b equal to 1. You have to do for differentiability also to get the a value. Differentiability, LHD from here, LHD will come from here. First one, e power x will remain e power x. Differentiation of ax will be simply a. Put the value of x as 0, so you get here e power 0 plus a. How much is that? Simply a plus 1. That's my LHD. Okay, e power 0 is 1, right? RHD now, Latin derivative, b times of, okay, differentiate this, sorry, so b times of 2 into x minus 1, that's my derivative. Put x value as 0, you get over here minus 2b. They are differentiable, means they are equal, so put it over here, I get a plus 1 equals to minus 2b, so I get minus 2 into 1 because b value is coming as 1, and a plus 1 is over here, it means a will be minus 2 minus 1, move this on this side, I get a equals to minus 3. So option number 3 is correct. Option number 3 is correct choice. Have a look. Not at all difficult, just understand that two variables, we need two equations. They have given differentiable, means it will be automatically continuous, the property of differentiability. One definition of continuity you're going to use, limit equals to function value, you get result of b equal to 1. Then you're going to use the definition of differentiability. LHD and RHD are equal, you get one equation from there. Put back the value of b as 1, answer of a is minus 3. Option number 3 is correct. Okay, let's move on now. 32 is done. 33. A function fx equals to e power 1 by x minus 1. Okay, we're looking for continuity and differentiability. Okay, all right, please check. So we'll start with the continuity first. We'll start with the continuity first. Now understand the graph of e power x first. That is very, very important. This is the graph of e power x. This is 0 comma 1, 0 comma 1. So if you actually try to look for this area, you'll have no result because it's going to be plus infinity. But when x tends to negative infinity, e power x tends to 0. Very interesting part. When x tends to negative infinity, e power x tends to 0. Alright. Now in that regard, because of that reason, what is happening over here? Check this out. I have 1 by x, right? So if x is 0, it means 1 by x will become what? 1 by x will become infinity. I will try to make this as negative and plus infinity. Okay. Right now it is going to be what? Plus infinity. I'll do one thing for RHL, right? For RHL, because how do you check for how do you check for your continuity? You find limit first, and to find limit you have to find RHL and LHL in this case. To find the limit in this particular case, in this question you have to find LHL and RHL. So for RHL, what are you going to do? Limit of the function x tends to 0 plus, x tends to 0 plus. Have a look. This will become what? E power 1 by x minus 1 upon e power 1 by x plus 1. Okay. Now I'm asking you to do what? Some changes over here. Have a look. Take e power 1 by x common in the numerator. This becomes 1 and this becomes e power minus 1 by x. How can I say that? How can I say that? Think about it. Think logically. If you multiply these two back, if you multiply e power 1 by x, e power 1 by x into e power minus 1 by x, what do you get? You get sum as 1 by x minus 1 by x. They cancelled. E power 0. How much is this? 1. I had 1 over here. I have taken e power 1 by x common. It becomes automatically e power minus 1 by x. Just for student who did not understand this step. Okay. Similarly, take it over here also common. E power 1 by x. What I get for this? Again 1 plus e power 1 by x. E power 1 by x. Alright. When I do that, excuse me, make a mistake. It was minus 1 by x, right? I have taken e power 1 by x common. Now this 2 will be cancelled. Of course, there is a limit over here. Limit x tends to 0 plus, x tends to 0 plus from the right side. Means positive 0 value. Means 0.000 like that. 0.000000 whenever it is come, as ending 1. So positive 0 value. When I do that, what happens to limit? Please check my RHL. Continue over here. It becomes in the side 1 minus, substitute now, 1 minus e power minus infinity and 1 plus e power minus infinity. How come, sir? If 1 by x is there, no, if I have minus 1 by x and I am saying x tends to 0 or x equal to 0, what happens to this? It will become minus 1 by 0. It will be minus infinity actually, because 1 by 0 is infinity, but there is a minus sign. It becomes minus infinity. What is that? E of minus infinity. Please check. When x tends to minus infinity, e power x is 0. This will become 0. 1 minus 0 upon 1 plus 0. Answer is 1. So my value of RHL is coming as 1. Very, very important. Very, very, very important. I know some of you might be feeling little, sir, why we are doing all of this? Why are you explaining so much? Because there might be somebody over here in this particular video, watching this video, that not able to understand this many basic things. So I am supposed to explain to them as well, right? Okay. So I'm going to erase this part over here. I hope this is clear now. And then continue with the LHL part. Okay. Just little bit patient, guys. Starting from LHL now. Same thing. So in this case, actually what happens is the limit will be what? X tends to 0, but from which side? From the negative side. So value is what? Minus 0.000. Yes, minus 0.000. So automatically a negative value is already there. Right before 0. What it means? Minus 0.0000001. So negative value is already there. So I have to make no changes in this particular case. In this case, we don't have to take common and basically cut it, because we don't need that value. In this case, we had 1 by x and x was positive. It means we have to make that e power minus 1 by x, right? But in this case, we already have x as negative, so we don't have to do that. Please check. So e power 1 by x minus 1, e power 1 by x plus 1. Substitute the value. You're going to get e power minus infinity, because we have 0 negative, minus 1, e power minus infinity minus 1, sorry, plus 1. I get the answer as 0 minus 1 upon 0 plus 1. nothing but minus 1 upon 1. What is the answer? Simply minus 1. This is what? LHL. So my LHL is coming as minus 1, RHL is coming as 1. So what happens is LHL is not equal to RHL, not equal to RHL. It means limit does not exist. Does not exist. Your answer is not continuous. Not continuous. What it means? Means non-differentiable. Answer is option number 2. Okay, not differentiable. Now, sir, do we have time to do all of this in the examination? You do not. Of course you don't. Then why are you teaching this much? Because that's my job, to explain you the concepts. I'm here to not help you just answer the question. I'm here to explain you the concept behind the question, right? So that you can think on your own if a different question like this comes in your examination. Have a look. In your exam, just do this step. Just do this one step. Sir, so much you did, you're saying this is also one step problem. Yes, it is. I'll show you why. Look, I'm looking for continuity, right? Continuity means limit should be equal to the function value at 0. Correct? Function value at 0 is what? Function value at 0 is given as 0. Function value at 0 is given as 0. If you find the LHL, easy to find. No need to use all of this method. No need to use all of this. Simply find LHL. What is LHL coming as? Minus 1. If LHL is minus 1, assume that even let's say RHL is also coming as minus 1 only. I am asking you to do what? Assume worst case, even if RHL is coming as minus 1. What happens in that case? It means limit exists and limit value is what? Limit value is minus 1. But is it equal to 0? No. Yes, limit exists. If we do not find this RHL part, and I'm assuming that limit is actually existing in nature and equal to minus 1. But is it equal to the value at the function for the point 0? No. Still discontinuous. Still it's discontinuous. So we don't have to do all of this. I taught you because I want to teach you. That's my job. But as a student writing the examination in KCET, how would you get this question in 15 seconds? Find the limits. Do one step over here. Find the limits. Limit is coming as minus 1, LHL is coming as minus 1, and which is not equal to. LHL is not equal to f of 0 because f of 0 is 0 and LHL is minus 1. They are not equal. It means not continuous. As simple as that. Option B, move on. Move on. Okay? This is a trick. So you guys keep asking me, trick for KCET. This is the trick. Every question has its own trick. How can you get to know that? By practice, by learning with me, watching my videos and asking your doubts. Sir, you are promoting yourself too much. Am I? But am I wrong? Whatever I'm telling you, is it wrong? Let me know. Do you feel that I'm giving you something which is wrong information? No, right? So this question number 33 is done. Question number 34 now. The last two questions of the day from again PYQ of 2025, this current year. Simple one. This is a simple question. Let's solve it. Parametric form. This you guys will do, without even looking at it. Okay. Derivative of y here. Sir, a is constant, so 3a. Derivative of sine cube will become 3 into sine, so sine square t, and sine derivative will be cos t. So this much you taught us so far. We can do this, right? 3a sine square t cos t. Derivative of x, we're going to do this. Again 3a and it will become cos square t, and for cos we'll have minus sine t. Correct now? How I'm getting this 3? 3 into sine square is the derivative of sine cube. Okay? Check this out. I'm getting here 1 of the sine getting cancelled with this sine. This cos cancelled with this cos. 3a is cancelled with 3a. I'm getting sine t by cos t. Sine t here. This is left, 1 sine t. And this cos t is left. So sine t by cos t. There's a minus sign. Put a minus sign. I get minus tan t is my derivative. What are they asking? Derivative at the point 3 pi by 4. So find here. dy by dt when minus tan 3 pi by 4 is there. So difficult. Tan of pi minus pi by 4. Which quadrant? Which quadrant? Second quadrant. The angle. Pi minus pi by 4. Second quadrant. This is pi. Second quadrant. Tan is negative. So it will become what? Minus of minus tan pi by 4. So minus of minus 1. Answer is plus 1. Answer is plus 1. Fourth choice. Easy question? Very easy question or not? Tell me. Had fun? Okay, 35th one now. The derivative of sin x with respect to log x. So this is easier than the previous one. Of course it is. So again, parametric form, which order? Function with respect to the function. If my function is, let's say p is sin x and q is log x. What are they asking? They're asking you dp by dq. They're asking you dp by dq. Okay. Derivative of sine will become dp by dx, dq by dx. Sine derivative is cos x. Derivative of log is 1 by x, comes up x cos x. Option 2 is correct. And this completes our session for one of the most important and easy and high weightage chapters of your KCET preparation, of your KCET syllabus from PU2, which is continuity and differentiability. Continuity and differentiability. Let me know what is your feeling after solving these 35 questions with me. Okay, and so that is it for today. That is it for today. For all of you who have joined me today for the first time, subscribe the channel. I'm telling you, I'm making a promise. We're going to do wonders over here. We're going to work so hard that we're going to ace our KCET. That's a guarantee. Okay, now if you've already joined and you know the routine, join the WhatsApp channel. What happens there? The class notes is delivered there. You have to download it and practice those questions. I'm going to conclude the session now. I had fun teaching you all. I hope you had fun learning from me. I'll see you again very soon. Till then, take care. Bye-bye.